Hello and welcome, everyone. My name is Dane Menke. I am the Digital Marketing Manager here at Regenesis and Land Science. Before we get started, I have just a few administrative items to cover. Since we're trying to keep this under an hour, today's presentation will be conducted with the audience audio settings on mute. This will minimize unwanted background noise from the large number of participants joining us today. If the webinar or audio quality degrades, please try refreshing your browser. If that does not fix the issue, please disconnect and repeat the original login steps to rejoin the webcast. If you have a question, we encourage you to ask it using the question feature located on the webinar panel. We'll collect your questions and do our best to answer them at the end of the presentation. If we don't address your question within the time permitting, we'll make an effort to follow up with you after the webinar. We are recording this webinar, and a link to the recording will be emailed to you once it is available. In order to continue to sponsor events that are of value and worthy of your time, we will be sending out a brief survey following the webinar to get your feedback. Today's webinar will host a panel of leading PFAS experts. With that, I'd like to introduce our panel for today. We are pleased to have with us Sabrina Shankman, reporter for the Boston Globe. Sabrina Shankman covers the climate crisis for the Boston Globe as part of the Into the Red team. She joined the newspaper in 2021 after reporting for 8 years at Inside Climate News, where she covered the Arctic. Prior to that, she helped produce shows for PBS Frontline and reported for ProPublica. Her work has won national recognition, including from the Society of Professional Journalists, the National Headliner Awards, and the Society of American Business Editors and Writers. We're also pleased to have with us Tony Bolasina, Section Chief at the Emerging Contaminants Unit in the New York State Department of Environmental Conservation. Tony Bolasina is a geologist with over a decade of experience in environmental investigations, where he has specialized in bioremediation of impacted agricultural sites and emerging contaminants such as PFAS and 1,4-dioxane. As Section Chief, he oversees investigations of geologically complex sites impacted by PFAS and 1,4-dioxane. Tony chairs the New York State Department of Environmental Conservation PFAS Working Group. The work group's goal is to promote cross-division communication and identify PFAS sources to prevent continued mass transport throughout the environment. We're also pleased to have with us Elizabeth Denley, Vice President, PFAS Initiative Leader, and Chemistry Director at TRC. Elizabeth Denley is currently serving on the Interstate Technology and Regulatory Council, or ITRC, PFAS team, is co-leader on the PFAS History and Use Naming Conventions sub-team, serves as trainer for this team, and won the 2017 and 2022 ITRC Industry Affiliates Award for her contributions to this team. She's also elected to serve on the ITRC board. She works on many different types of PFAS investigations with a specific focus on risk liability assessment, management plans, chemistry, sampling procedures, data interpretation, forensics, QA/QC, and analytical methodologies. We're also pleased to have with us Grant Carey, President of Pour Water Solutions. Dr. Grant Carey has more than 30 years of experience focusing on the characterization and remediation of large, complex sites. He specializes in PFAS, fate and remediation, data visualization, environmental forensics, and groundwater modeling. Dr. Carey is currently participating on a number of CERDIP ESTCP projects for the U.S. Department of Defense to evaluate PFAS remediation technologies. We're also pleased to have with us today Maureen Dooley, Vice President, Industrial Sector at Regenesis. Maureen Dooley has over 25 years of experience in many aspects of the remediation industry, including project management, research and development, senior technical oversight, remedial design, and laboratory management. All right, that concludes our introduction. So now I will hand things over to Sabrina Shankman to get us started.
Thank you, Dane, for the introductions. I'm Sabrina Shankman, climate change reporter at the Boston Globe, and I'll be moderating today's discussion. I'm really happy to be here because from where I sit, PFAS is one of the issues that's top of mind with our coverage, and will certainly be leading a lot of what I'm writing about for some time and a lot of what all of us are thinking about. So as likely everyone who's listening to this and participating knows, PFAS are a group of widely used man-made chemicals that you can find just about everywhere, from takeout food containers to the foam used to put out fires. And we're learning they're now being found in our water, our soil, and even our blood. During this discussion, we'll be talking about how best to address this issue, the challenges on the ground, and the solutions that are being developed. So you've met all of our participants already, thanks to Dane's introductions. I'd like to start things off by quickly talking about where things stand. What do we know about the extent of the problem with PFAS? We'll later be talking about how to address these problems, but for now, just how prolific are PFAS in our environment? How do PFAS get from our products to our environment? Liz, wondering if you could start us off, and others feel free to chime in too.
Sure. So, from a practitioner perspective, right now, there's so many challenges around PFAS. We know PFAS are a class of chemicals. There's probably up to around, 15,000 different PFAS chemicals. We know that not all PFAS behave the same, meaning, they do not move in the environment, in the soil, groundwater, and surface water the same. They don't all bioaccumulate in humans and animals the same. Some will bioaccumulate for long periods of time, and some will be removed from our bodies immediately. And their toxicity is not the same either. And just because, one PFAS chemical, such as PFOA may cause cancer, does not mean all PFAS chemicals can cause cancer or be harmful in some way. And another challenge we're finding with PFAS, and it's not necessarily a bad thing, but the general public, as you know, is very aware of PFAS, different than what we've seen with any other chemical. I mean, we have Netflix documentaries, we have a Hollywood movie about PFAS. PFAS is in the news a lot. And what I hear from the public many times is, that they want zero PFAS. And zero PFAS is almost impossible when we know, as you said, PFAS has been used in so many different products, so many different industries, products that we all use in our homes, throw down our sinks. So PFAS are pretty much ubiquitous, and we need to be concerned with the level of PFAS in our drinking water, food, and other things we ingest, which may cause harm. I think we just need to, kind of put it in perspective and understand that there's so many different challenges with all of these different types of PFAS chemicals.
But it's one thing to have PFAS in my takeout container or the coating on a pan that I'm using. It's another to have it, show up in the milk that I'm buying from the grocery store because it's present in the soil at a farm. How does it make the leap? How does it get from one place to another? I don't know, Maureen or Grant or Tony, do any of you want to chime in on that?
Sure, like one way. So one of the reasons it is so prolific because it is very widespread in the environment. And one of the reasons for that is because we've been using PFAS for 60 plus years in a lot of different applications without being aware of how harmful the PFAS chemicals are. So just to give you one example, when eventually PFAS has gotten into people's blood through many different ways. And it is something that gets into our septic systems. It goes into septic sewage treatment plants. A long time they weren't testing for PFAS. They didn't know it was harmful. So that water was going through the treatment plant and then going into rivers, into groundwater. So it's become very widespread in a lot of different ways. But now we know it is harmful. A lot of steps are being taken to try and counteract that. And maybe Tony and Maureen could talk more about the regulations currently being put in place to try and reduce the risk.
Let's put a pin in regulations for one sec, because we're gonna spend some time talking about those, both at the state and the federal level. But kind of going back to the basics, though. I mean, how are these primarily being discovered? We keep learning about new locations where PFAS are found. Tony, how is the state of New York finding out about new places? Like, how are people discovering it?
Sure. Yeah, I think, like a lot of the Northeast states here with some of our industrialized past, we've kind of been more ahead of the game with regards to PFAS. I'll take a big step back and say kind of nationwide, this came about due to EPA's UCMR, the Unregulated Contaminant Monitoring Rule, the third iteration of that. They had PFOA and PFOS, as well as I believe 4 other PFAS compounds as part of that monitoring rule. And that's where they found kind of the prevalence of PFAS. Across the country, and then specifically the Northeast with some of our industries that have used PFAS, specifically PTFE coaters, polytetrafluoroethylene. There's some industries in New Hampshire, Vermont, and New York, and PFAS is a primary ingredient historically in PTFE. That's kind of where it started nationally, and then specifically in the Northeast. So that really triggered New York, as well as some of the other Northeast states that I can't speak for, but New York, to kind of just go full send on where is the PFAS. And that triggered us to do a variety of industry surveys that we suspected to be users of PFAS. It required, it started the requirement for sampling at, landfill leachates, any of our listed sites. So we had a variety of actions in place to identify, where the PFAS are. And I would just say, now kind of coming full circle on that, what we ultimately did find is that while there are, isolated locations that have elevated levels, we would say those like industrial source levels, we did also find that most, if not everywhere, we are finding the PFAS, but at much lower levels. So, there is a need to set standards at the low level. New York State is 10 parts per trillion for PFOA and PFOS, but there is that understanding that the sources that have the much higher levels, 10,000 plus, 40,000 plus parts per trillion, those are our true sources. So it's kind of a twofold approach that we have to take. Go after those isolated, elevated industrial sources, but then also figure out ways to get those low levels out of our system. And maybe that's another topic for us to discuss as we proceed.
Yeah, that's actually a great segue. Because I want to spend some time talking about, what do you do? What are the solutions that are available to you once you have discovered one of these big sources? I know, Maureen, you're doing a lot of work around this, and wondering if you could start us off, and then we'll open it up to others. Once the PFAS has been found, what can you do about it?
Sure. No, I'm happy to. And, and just getting back to the sources and some of what Tony was saying, I say, what are the sort of sites that we're currently seeing? I would say probably the majority, at least, from my perspective, have had a lot of association with the AFFF. So that's the firefighting foam. So you're going to find that associated with airports, fire training, a lot of oil, just a wide range of industries that have had any sort of fire suppression equipment and any fire suppression testing, and of course the Department of Defense and any of those types of sites. So in many of those situations, we may have a fairly refined source that we can look at, and this might be in opposition to, say something where the source is an air deposition that might be an industrial, source that where it's kind of a little bit of everywhere, and again, I'm not getting into the landfills and that sort of thing. So getting into, okay, what can you do? What are the options that are out there? So I'm going to talk about like the sources and not the drinking water side, that sort, but there, the challenge with the targeted PFAS compounds like PFOA and PFOS is they really aren't subject to any chemical or biological degradation. So that's why they're referred to as the forever chemicals. They just seem to, stick around forever. So you really have, two options. Like say if we're looking at groundwater, say we're at a particular location, say an airport or where you had some fire training, you may have some material in the soil, and that eventually, because of rainwater, will end up leaching and getting into groundwater and can move around. So you have the choice of either trying to stabilize it in place, or you're going to put an extraction well in and pump and create a hydraulic barrier and pump it out and extract it. If you're doing the extraction sort of situation, it's necessary to you get the groundwater out of the ground, it goes through a treatment, say ion exchange, carbon filter, and then you have the contamination that you need to manage there at that point. And so that may end up going back to a landfill or incinerated. So you have this whole management. And then the other approach is to try to, in essence, stabilize it in situ. So you can, inject, like for instance, a carbon material, colloidal carbon, and create a filter underground. And when that allows you to do is to capture any of the PFOA, PFAS, or targeted compounds, and it stabilizes it, keeps it in the ground. And what the end result is, you're eliminating any exposure. So what that means is if you have a property and you're concerned about drinking water wells that might be off the property or an eco receptor, you're able to keep the PFAS contamination from moving off site. So that's sort of the kind of the two approaches that are there, just very generically. And I know Grant or some other folks may want to get into a little more detail, but that's the kind of the world I deal with, and trying to say, okay, now you have it, what can we do?
Sure. And actually, Grant, I'm wondering if we could pass this over to you. Maybe you could talk to us about some specific examples that you've come across where, you've taken one approach or the other, and why.
Sure. So I'll talk about, so I'm working on a CERTA project, which is for the US Department of Defense. There's a group, actually, sorry, not CERTA, it was a different project, but there's a group called Aptum, led by Paul Hatzinger. And through a Navy research grant, they actually took a technology that Regenesis developed that Maureen was talking about. It's activated carbon, really, really small particles of carbon that you can inject into the soil right through the middle of a plume. And that activated carbon absorbs PFAS really strongly. So what we do is we put in these barriers so that groundwater flowing through the carbon barrier, which is almost like a wall of carbon, the PFAS filter out by absorbing onto the carbon, and you get clean groundwater flowing through the outside. So this research group led by Paul Hatzinger at Aptum for this Navy project, they've done 2 years of monitoring to show that, yes, this is really effective for treating the PFAS of concern. And even in the Department of Defense right now, there's got to be 6 or 7 different CERDIP and ESDCP projects looking specifically at using activated carbon or other particulates in the ground to try and create desorption barriers. So this is becoming, it's proven to be effective, and it's probably going to be something we'll see more often applied at sites, just through all the research.
Sorry, just quickly, the carbon stays in the ground permanently to continually address it, or is it removed at a certain point?
So good question. So the carbon stays in the ground, and PFAS, if you have a source ongoing for decades coming through that barrier, eventually the PFAS does start to move through the carbon, and eventually it's going to break through. So what we need to do, say we design this to have a lifespan of say 20, 30, 40 years. Down the road, we have monitors in the barrier, and we know when PFAS are getting close to the end. We have to re-inject, or even there are technologies in development where we might be able to treat that carbon in situ. So there's different ways we can deal with it, but it does stay in the ground. And then down the road, we are going to have to come up with ways to deal with that spent carbon. But usually what we're going to do is re-inject right down gradient and create a second barrier to catch that PFAS coming through. Eventually,
sorry, so just to touch on that, Grant, one of the things too is that if we're able to stabilize the source, then you may only have a fixed amount of, say, PFAS contamination in a particular situation. So in some cases, using the modeling and a lot of the predictive tools that Grant has, we may be able to design this such that even if you can stabilize the source where you may have some of these high concentrations, you can also keep this protective really for, almost as a one-time, scenario. So that's possible in some situations.
So to put it in non-expert journalist terms, you're essentially buying yourself time using this approach to figure out what the source is, address that, and then you're not needing it for 20, 30, 40 years because you've already dealt with the source of the PFAS. Is that right?
Yeah, partly that, or what I see it as, it's a good solution now to stop the PFAS plumes from moving. And down the road, I know there's a lot of research being invested by Department of Defense on more source treatment options, technologies that can be destructive. So I think 10, 20 years down the road, we're going to have more options for dealing with the source. We can inject carbon, we can try and destroy the PFAS. So it's really about trying to stabilize the situation now, buy us some time, and then longer term, we can figure out what we're doing with the bigger picture. But every site's different. Some sites you can put it right in the source and you're done. Other sites you might have a multi-phased approach. Really depends on the site.
Yeah, and I think that's exactly the point. Everything has its unique characteristics, and so you have the range of outcomes for a particular site and in approaches, and that's where we can look at all the tools that are available to us to see what makes sense.
Sure, Tony, I'd love to hear from you on this.
Yeah, I just wanted to kind of expand on what Grant was just saying there, the kind of forward-looking approach. While definitely the colloidal carbon injections is a great option to kind of keep that PFAS stuck in the ground, prevent its mobilizing off-site and whatnot. The forward-looking is definitely, as Grant alluded to, electrochemical oxidation, supercritical water oxidation, foam fractionation, where you're taking a waste stream of water and you're subjecting it to, turbidity, and it kind of creates a foam that the PFAS concentrates in, and then that can be destroyed through a variety of techniques. Like I said, high levels of oxidation through ECO or supercritical water oxidation. And of course, incineration is kind of a long trusted approach to, burn your contaminant, if you will. PFAS, of course, you need to maintain a high level of temperature that can be consistently maintained and monitored. And now that we have the EPA air monitoring OTM 45 and 50 that tests for those products of incomplete combustion, we can hopefully kind of confirm the efficiency of the incinerators. So I think we are really optimistic about that going forward. And then to just kind of take the taboo away from it, PFAS contamination. Yes, it's this kind of scary new emerging contaminant, but just kind of these traditional engineering controls at a site where you're, routing surface water away from a contaminated area, improving capital improvements across the site, capping it so surface water cannot infiltrate that contaminant mass. There are, a wide spectrum of decisions we could make in remedying a site. So I'm kind of optimistic with that view going forward.
We love optimism. That's great. Once you've found a source, you have a problem. How do you determine where it has come from? What is the investigative work that has to go into that? Liz, can you touch on that?
Sure. So that's a very intense part of the whole, story here. Starting out by collecting the proper samples, obviously in the field. PFAS sampling also can be a little bit more challenging than sampling for other types of contaminants because PFAS are used in so many different products. So using proper sampling techniques and whatnot to collect the right samples, the right groundwater samples, soil samples, things like that. But then when we send the samples to the lab, we want to do some kind of forensics, right, to determine where the source is, right? It's not always obvious, or we might think it might be an obvious source, and it might turn out to be something completely different. So we have ways in the laboratory, different types of analyses we can do. There's one analysis that we all do for targeted 40 PFAS chemicals, but then we also take that, we look at different ratios of different chemicals to each other. We can do a total oxidizable precursor assay analysis to also see how certain PFAS chemicals are transforming to give us an idea of what the potential source might be from possible precursor PFAS as well. And just kind of using all that information together to try and come up with a source. And for an example, we just recently worked on a site where we were sure when we went into the site, it was near a like a dry cleaner type site, industrial site, and we thought for sure the PFAS was going to be, that we found was definitely going to be coming from that industry. And it turned out after we did our study and our forensics that it was actually it was a large residential development. It was coming from their own septic systems. So, and there's also forensics that can be done around that. We did some analyses for artificial sweetener, which is things you see in a septic system, or boron, which comes from soap products, things like that, which help us kind of pinpoint the source.
Is there PFAS in artificial sweetener?
No, but artificial sweetener is a sign of that maybe the contamination is coming from septic, because it's something that's being thrown down our drains, right? A lot of people use artificial sweetener.
I was wondering the same thing.
Yeah.
I'm glad you asked.
No.
I was like, I gotta go. Okay, that's a relief. Thank you for clarifying that. But that is super interesting. This is the next thing I was gonna ask about, is when there have been misconceptions, thoughts that something is a source, but then through analysis you've determined that it's something else. I mean, Tony, have you come across this in New York at all, or any kind of misconceptions around this in general?
Yeah, and just to kind of continue on what Liz said there, so so we kind of regulate a handful of PFAS compounds, while there's a very large family of PFAS. So specifically PFOA and PFOS are the two that we're dominantly regulating across all the states here. And I have just a quick example to point out where I had a site that's a PTFE coater, that polytetrafluoroethylene, that's basically like a Teflon type of coating. and the signature of the PFAS at that site is just dominantly PFOA, because that was the ingredient used in that PTFE over the years. And since transitioning PFOA out of that PTFE, they've used other types of carboxylic acids, which is what the group that PFOA is in. So there's this particular responsible party that is this manufacturer, and they are pointing the fingers everywhere else. You know, it's not my PFAS, it's not my PFAS. So across the road is an airport. So what do airports use in historically? Aqueous film forming foam, AFFF, to put out jet fuel fires. So that's, you know, a valid point that they may have used and likely did use AFFF. So when we expanded our sampling off this site, we have to be cognizant of this, that there are multiple sources. So we always look at the whole spread of PFAS, not just the two that we're regulating. And what we ended up finding was closer to the airport, we started noticing these fluorotelomere PFAS, which is a common replacement to PFOS that was used in the AFFF. So PFOS, phase that out. What do they use? These 6,2 fluorotelomere sulfonates. And there you go. It's using that forensics was able to easily identify two sources. And then to your second point, you know, these kind of misconceptions that sometimes the public have, you know, all we can do is be, you know, especially as a government agency here, we're just fully transparent. All of our final work plans, final reports, we share. Any given week, I'm probably on the phone for 2 hours talking to residents, concerned residents in areas, and I just try to educate them. We have a variety, you know, our websites, we're continually updating those. Each of our respective divisions have, you know, their public participation specialists. I think it's just really vital to just be transparent, share the information that we have, fact sheets, be available for public meetings, and overall that's been very a positive response.
That's great.
Get the truth out
Grant,
there.
I'm Maureen, curious. I found that so interesting, this idea that, you know, you can go in thinking one thing is the problem and then it ends up being something else. Maureen and Grant, either one of you, do you have examples where you've run into this in your work?
One example, it's actually not my work, but it's a friend of mine, Dan Bryant with Woodard Curran, did a really interesting study where he looked at soil background concentrations through the whole state of Massachusetts. I think 60 or 70 samples across the state, because there are a lot of sites that have low levels of PFAS in soil. So the question is that coming from the site? Where is it coming from? And what they found, and what's been shown by other studies across other states in the Northeast, is there has, through atmospheric deposition, it looks like there's been plumes of PFAS historically that have deposited into soil. So if you're getting low concentrations of PFAS, it may not be from the site. You've got to kind of really look at background. And that, because same thing with groundwater. I've got sites where we've got elevated PFAS above cleanup criteria coming into our site from up gradient, where you've got a lot of industrialized areas. You might have low level plumes that have been contributed to by one or a number of industries. So it's really important with looking at these sites that we identify what's the background in soil, what's the background in groundwater, because we can't clean up below background. So that's something, you know, we'll have to compare background to cleanup criteria, and that's a key thing with site characterization we have to look at for sure with PFAS, far more than with any other chemicals I've worked with.
Interesting. What about you, Maureen? Anything you would chime in on this?
Well, you know, honestly, at the stage that we get involved, we're more in the, we have it and we've got to do something with it. So it's a little less about where it's from. It's to keep it from going someplace else. So in that sense, so I probably can't chime in with some of the stories that the other folks have.
So this past year was a big one when it comes to PFAS and regulations, in that we saw the federal government for the first time introduce regulations related to PFAS levels for 6 specific chemicals. Would love to talk about what these regulations do and do not cover, and also what challenges may exist in order, like, in meeting these standards. I don't know who wants to take this first, Grant or Tony. Do you want to head this off?
Do you want to take
Sure.
it?
I mean, yeah, I'll start it off. So yeah, you're referring to the 4 parts per trillion MCLs for PFOA, PFOS, and then there's, I don't have it all memorized actually off the top of my head, but there's a hazard index for several other compounds, including Gen X and PFBS. So I think that's, you know, again, these are bioaccumulative compounds. The levels need to be set low. I understand there's like a frustration out there that, how can we achieve it? There's background levels that aren't being considered. Like Grant said, there's a need to have that understanding if we're going to assign, blame to a small water supplier, a mom and pop business or something like that. So I totally understand those frustrations, but the truth is, I don't want these compounds in the environment. So at New York State, of course, we already had levels that were relatively low, 10 parts per trillion lower than the prior 70 PPT MCL from EPA. So if the federal limit is lower, of course, we have to abide by that. There was some time frame component to that where I think the suppliers had till 2029 to implement actions on that. So I'm not sure what the administration changed in the coming year, if they'll keep the levels that low or not. But of course, as a state, we would abide by the lower federal levels if they stay that way. But at New York State specifically, we are, invested in keeping our levels as low as we can, and doing that kind of twofold approach where we go after the obvious industrial sources and then implement a variety of laws and regulations to get PFAS out of the supply chain. That I think will ultimately be the need to get PFAS levels lower so that they're not exceeding like a 4 PPT MCL if there's no obvious source nearby. It needs to get out of the supply chain ultimately.
Yeah, I know from my own reporting in Massachusetts that, when the federal standards came out, similarly, the state of Massachusetts has a set of regulations, but the number was slightly higher for where there's overlap with the EPA. There are some things that the state of Massachusetts regulates that the EPA does not, and vice versa. So they were looking at how to expand the regulations. There's an ongoing conversation to kind of embrace what the EPA is doing while continuing to regulate the ones that the state of Massachusetts had deemed relevant. Is New York having a similar conversation about that?
Yes, absolutely. Like our public water suppliers are required to meet the EPA MCLs. So that's kind of, a health situation. We have our county health departments and our state health department that oversees all the counties, and that's, ongoing. We've already had a lot of public water suppliers be required to sample for our 10 PPT drinking water MCLs that we set, I believe, in 2021. So that kind of ball was already moving, and now that data is just for the public water suppliers to look at with respect to getting it down to 4 parts per trillion by 2029.
All right. So,
do you mind if I
oh, go right ahead, Grant.
One thing to add to that. So something that I found really important, what was covered is with the EPA regulations, the compounds, like I work on a lot of sites where former fire training activities occurred, high concentrations of PFAS. A lot of sites, the remedy involves either in situ absorption to carbon or other particulates, or pump and treat, you're treating it above the ground. Those all involve absorption. So the regulations that came in, they're mainly going after long chain PFAS. They're the ones that absorb the most, so they bioaccumulate the most in our bodies. That's why they're the ones that have regulated criteria for the most part. What's not in there are criteria for short chains like PFBA and PFPEA, which really do not absorb well in situ or above the ground. So if those had been included, that would have, I'm not sure how we would remediate sites or treat drinking water. It would really make things difficult. So it seems to be the focus is on these long chain PFAS that absorb well. So we have remedies that go after those. So I think that's a key thing for me. I mean, the numbers, and to be honest, the numbers they're low. And I'm doing a fair bit of modeling. How long does it take to reach goals? Let's say we put in an in situ barrier or a pump and treat system right in the middle of a plume. How long does it take the downgrading part of that plume to kind of flush out? And what we're seeing in the field and with models, it's going to take a long time to reach 4 part per trillion down gradient. So I just think we need to make sure we have good realistic expectations of times to achieve these goals down gradient of our points of compliance.
It's probably also, though, important to understand the other PFAS that are present, right? Like the other short chain PFAS, because even if we are treating just the longer chains, where those other PFAS, if they're still present, are going to be using up the treatment system, the filters, whatever, and are going to be contributing to the effectiveness of that treatment. So it's important to understand not just the ones that are being regulated.
And even other contaminants on top of that.
Right,
So,
right,
we talk about
exactly.
PFAS, but anything that can contribute to, the absorption capacity, if you ex situ, in situ, you have to truly understand that. And I think something else just the thing on the regulations, like, because these are drinking water standards. And so sometimes when we're working in the world of groundwater, now do you have to, are you attempting to, do you necessarily have to achieve drinking water standards or not? But I think, you know, one of the overreaching pieces of this is you want to start of the source into the drinking water system. So I think the idea that and you're starting to see this in different states. Okay, like I think it's been talked about before, where are the sources, not the source on the site, but what are the sources that are contributing into the overall drinking water quality, so how you can, you know, reduce what's coming into the system. And so just helping to stop that mass that's getting into there and all contributes, it will help to the overall quality. And really, I you know, the idea, you know, what's coming next, I don't, you know, we're still going to have to do this regardless if it's 4 parts per trillion, 70 parts per trillion. You know, there's still PFAS in there that needs to be, you know, mitigated and dealt with.
Right. And the MCLs, once the EPA sets MCLs, states many times will adopt those for their groundwater standards too.
Yeah.
So that's what ultimately usually happens. So
I just wanted to kind of put a bow on that, what Maureen was just saying. I think that's identifying that mass transport of PFAS is just so important. So we're kind of talking about this background issue where, let's say EPA, you know, it stays at 4 parts per trillion, how hard that is to meet, especially if you're in a dense rural a dense area where there's people on private wells and supply wells and whatnot, and it could be coming from wastewater, septic systems and whatnot. I would say like all of that, like identifying that in the environment, which is what we have seen, that there are levels above 10 parts per trillion per se that have been not attributed to an industrial source. That has 100% happened at a couple of our sites, especially in these kind of densely populated areas that have, you know, shallow fractured bedrock. So my view is that that is a function of what has happened prior to the regulation of these compounds, right? So now what has New York State done? You know, we have 24 different programs and divisions, if you will. You know, 5 or 6 of us are really focused on PFAS, and we're always communicating so that we're not just passing that mass. So you have, like Maureen was saying, we have drinking water standards, but we also have, you know, groundwater standards. So our Division of Water put out these ambient water quality numbers that are actually even lower, 2.7 BPT for PFOS and 6.7 for PFOA. So what does that mean now? Well, when they're reviewing their discharge permits, they're comparing to those numbers, right? And then so we have all of our discharges that maybe weren't being monitored for PFAS because we didn't know it was a thing for all these years. Now they're being required to look at those levels in their discharges, and if they have exceedances, they look upstream. They look into all these industrial wastewater discharges that are feeding into that treatment center, if you will. And then we have all of our landfills that the leachate was not being monitored. Now it is. That leachate would just be sent to those wastewater treatment plants. And then we have all of our remedial sites that we're just kind of identifying all of that mass, severing all of those mass transport pathways. And then that in conjunction with regulating it out of food packaging, apparel, carpets, et cetera, which is what we're doing. Ultimately, I hope will now 10 years from now, what are we going to see? Like, hopefully that will be much lower, but that's the need, right? If other states are kind of just getting onto this now, once EPA said it, because they didn't have their own stringent standards, like that's the path forward. Is you have to have that inter-division, inter-program communication, identify that mass transport, and sever it wherever you can.
Okay, but it seems like the big kind of uncertainty here is what happens with federal regulations. Obviously, we have a new administration coming in. You know, already we've seen calls from Senate Republicans to more narrowly define PFAS regulations. We've seen, you know, Project 2025, which everyone's talking about all this year, blueprint for the next Republican administration, calling for the defunding of major research into toxic chemical exposure, vows to make the EPA more open to industry science. So there is this, you know, there are at least signals that things could change from the directionality that we've seen from the EPA in the last couple of years under the Biden administration. And yet we don't really know, like in this moment right now, we have no idea. So there's this level of regulatory uncertainty that we will likely be sitting in for some amount of time. So from where you all sit and the folks that you work with, obviously Tony, you're in a different situation being with a state regulatory body, but I mean, how does that regulatory uncertainty kind of affect the people that you're working with and the work that you're doing? Do things just continue ahead as planned, or does it change anything? Liz, why don't you?
I can speak to that.
Oh, sorry, go ahead.
Okay. Yeah. So regardless of what the new administration does, PFAS regulations are not going away because the states have been ahead of the EPA, and the states are going to continue to regulate PFAS. So, and the states are the ones who are implementing all these PFAS product bans and whatnot to, try and get this out of our supply chain. So with the work that we do, we're trying to help our clients, still just be ready for these product bans, be ready for these regulations, to understand what their potential PFAS risks or liabilities are if they haven't evaluated them yet, how to potentially mitigate and manage any liabilities around PFAS that they might have, just so they are ready for all of these regulations that have been coming out over the past year and that are they're going to continue to exist, again, because of the states. And also, I just want to point out too that these regulations have also really impacted, transactions. So like we work a lot with private equity firms, buyers, sellers, lenders, investors, insurance companies, and PFAS is part of every transaction now, regardless of what the company does. It's just has to be evaluated, has to be due diligence around it to make sure there's not going to be a risk to the buyer around the upcoming PFAS regulations and what's happening now. But I do not think that PFAS regulation is going away. I strongly believe that.
Great. Anyone else want to add on to that?
I'll just add a piece just from observations from my view. I obviously don't know anything, but I mean, the idea that those regulations get repealed seems less likely. Maybe is it altered, but the repeal, I don't know. Because I mean, I believe that even in Congress or that there has been bipartisan support for the idea that, say PFOA and PFOS are hazardous compounds. So I think there's probably consensus there. What happens next? And I think the uncertainty of, is it 4 parts per trillion or something else? I mean, where that factors in may factor into costs, may factor in, what technologies I can use in the approach. But I agree with Liz. I don't think it's going away. And it seems to be the sense that people have, we don't, obviously don't know the future. Kind of the genie's out of the bottle. People know about it, and, people want, clean water and food and air. So, that's right. So that's just sort of where I am. I think it may change a little in the federal, but the overall picture, people still going to have to be responsible if there's issues on their site.
I think I also want to say too that, we're in the Northeast, and the Northeast is ahead of the game. Massachusetts, New York, Connecticut, New Hampshire, Vermont, Maine, they are all heavily regulating PFAS. They are way ahead of a lot of other states, and they're not going to be cutting back regulations.
I say even the Department of Defense, with the programs that they have in place, that they've undertook a very significant investigation program, and they're evaluating all of their different facilities. So, in some respects, I mean, they're continuing to move ahead and have 5-year plans and budget associated with PFAS and remediation and investigation, all of that.
Yeah, I was
Just
gonna. Go ahead, Grant.
Okay, just one quick point. So Maureen brought this up. I think it's important to note. Let's say the levels did go up for PFOA, PFAS from, let's say, somewhere to between 4 and 70, just as a guess, if they did change at all. And if they don't change, we already set. But there's a lot of sites with much higher concentrations. Even if the criteria go up, I don't think the remediation technologies change, whether they're doing in situ absorption or above ground pump and treat. they're going to be using the same technologies. It might just reduce their costs a little bit if they're doing pump and treat, but not, I don't think by a lot. What would really change is if they added more chemicals that are not
Hmm.
able to absorb well. That would be a game changer, but I don't think that's the case with the new administration.
Agreed.
To me, the smaller sites, the ones where they're between 10 and 70 nanogram per liter in groundwater, they're the ones most affected. And the drinking water systems with the really low but slight exceedances, they're the ones who might be more affected if the numbers go up for sure.
Yeah, I was going to just chime in on, I can't speak federally, of course. I do think I agree with Liz that, the cat's out of the bag, the regulations with respect to PFAS. I think federally too, are only going to, expand because we're so narrow viewed with respect to only looking at, 2 compounds, 6 compounds. So I think that, the flavor out there is that there will be a broad approach, total PFAS approach, but we're limited by, the analytical methodology for that currently, but there's some work in progress with regards to sampling and identifying what is total PFAS, but that needs to be defined. So I'm not sure the specifics of this, this, what was it said that somebody put something out there that, some Congress folks are looking at defining PFAS. I'm all for a proper definition of PFAS that can be agreed upon. And I do understand that not every PFAS is as toxic as a 13 carbon chain length PFAS. And there are technically maybe single carbon fluorine bonds that maybe there's, no bioaccumulation or no toxicity. I'm not a toxicologist, so I can't speak to that, but I am all for a more proper definition of PFAS so that we can kind of regulate it more wholly instead of piecemeal. Now, with that being said, I don't want to, for all the listeners out there, I've taken a good look at the data that we have from 1,400 sites that we've looked at PFAS data on, and the majority of the sites, if it exceeds for total PFAS, if you will, the compounds that are driving that are PFOA and PFOS, because those are the ones that were purposely manufactured. But the unknown is, of course, the phase out from those compounds, where maybe there's compounds we're not analyzing for, which is what Liz alluded to. Like, how do you find out if there's some crazy PFAS compound that looks like PFOA, but it's got a little branch on here we're not analyzing for it with our 1633 method? So you use this total oxidizable precursor and you kind of break it down into that. But to get rid of all those unknowns, ultimately defining PFAS consistently and then, analyzing for total PFAS is something I'm hopeful for going forward. And I think that's ultimately where this will lead.
Okay, so jumping off of that, I wanted to ask each of you to talk a little bit about where you see the field going. What's next? What are the big things that we're going to be talking about a year or two from now that we're not necessarily talking as much about already? I think you've all given some examples in your discussion in the discussion so far, but wondering what you would point our listeners to. Maureen, would you like to start?
Sure. And again, from my perspective, I'm looking at the remediation side of things, and I think there had been a lot of hesitation for, say, some responsible parties or, to even get information. I'm waiting to see what's going to happen. I'm on the fence. And I just think at this point, they're understanding that there's a potential risk and liability, and it's time to move forward. And I think we're just going to see more projects start to move forward. I know there's the uncertainty with the new administration, but I think the consensus here, and I think with most people in the field, that we still have to do something. So I think just looking forward, I think we're just going to see more sites starting to get worked on, understood better, and hopefully get a little cleaner.
All right. How about you, Grant?
It's a good question. So I think I'm looking more, so 1 to 2 years, maybe the next 10 years. I definitely agree with Maureen. I think we'll see more sites going into the RI phase, FS phase, trying to figure out what they're going to do. Now that we do have federal regulations, I think that does set things in motion, which is good because we can start to address what we need to address. I think we need a bit of a different paradigm with PFAS sites, at least for larger sites, than what we've typically had with other chemicals like chlorinated solvents. One of the challenges with PFAS that's different is we really don't have a lot of source treatment options right now. I know that Department of Defense is investing really heavily in research and development on PFAS destruction technologies. But I think for the next 5 to 10 years, we're probably going to focus more on containment technologies, like the technologies Regenesis has that Maureen talked about, plume stop, source stop. I think containment for at least the next 5 to 10 years is probably what we'll see a lot of investment in. And I think just a remediation time frame. I do think we need to focus early on with mass discharge reductions, orders of magnitude where we can and where we need to, and just realizing that it's going to take longer to reach these really low cleanup goals. But as long as we've got the ability to do the mass discharge reduction and we can let things catch up, I think that's probably where we're going. And then eventually we'll get into source treatment down the road when technologies are available.
All right. How about you, Tony? Where are we headed?
Yeah, I think I think New York, like Liz said, the Northeast is kind of already ahead. So with respect to New York, I think we're going to be, regulating more PFAS, kind of looking at the family more broadly, better understanding of the family of PFAS and how they can degrade over time, better understanding of the fate and transport of different PFAS, maybe more specific. If we keep looking at them individually, specific guidance values for different PFAS based on their tendency to travel, to leach from, or to absorb from, soil to, or partition from soil to groundwater, et cetera. We have a good amount of sites that are already in remedial action. I think we're going to see a lot more going into remedial action. I hope to see some of those creative destruction technologies implemented. I hope to see the air, the OTM methods promulgated more widely, so that we can understand the efficiency of incineration and whatnot to send soil there, have it be incinerated and then beneficially reused. We have to obviously be cognizant of sustainable remediation too. We can't just be shipping off football fields of soil to the other states that have less stringent regulations. That's not what our goal is here. And then I think, broadly speaking, across other states that maybe aren't as far ahead as the Northeast, I think they might be earlier on in that game of identifying where the PFAS is, and I hope they would follow suit with what some of these Northeast states have done, and understanding the obvious sources versus the less so obvious sources, and then understanding the importance of kind of regulating the PFAS out of the supply chain and preventing that mass transport, because ultimately that's going to be vital if you're going to get those background levels down, is to just get it out of your emissions points, your wastewater discharge points, and out of your leachate and all that. So.
All right, great. And Liz, would you like to add anything? What do you see happening there?
Just a couple of things. I know for sure, I think we are going to see some litigation challenges to the EPA's MCL and CERCLA hazardous substance designation. We're probably going to see more litigation in general around PFAS. I expect we're also going to see a lot more product bans from other states. And as Tony mentioned earlier, the industry permits, so just like wastewater discharge permits, air permits are probably going to begin to have some more PFAS requirements added. And I expect we'll see many more businesses kind of researching alternatives to PFAS where possible. And just in addition, like the thought leadership around PFAS in the last 5 years has been overwhelming. And the scientific community really, we've come together, and I think we've done amazing work. So I think that's going to continue. I think we're going to find more cost-efficient, effective ways to treat and destroy PFAS. So.
Great. All right, well, I'm going to shift gears a little bit. We got a lot of questions that were submitted ahead of time for all of you, and we unfortunately can't get to all of them, but I'm going to get to as many as we can. And for those who are attending this is probably going to go over the hour just a little bit, but bear with us. We're just trying to get to all these great questions. So the first one that I wanted to put to you all is this. Is it a losing battle to continue to investigate contamination when PFAS are still in use in daily products? How will enforcing EPA maximum contaminant levels change the approach and progress that has already been made for many sites? Who wants to touch on this first? I think it's something that each of you probably has some insight. And maybe Maureen, do you want to?
Well, I'll just start from my perspective. Yeah. I mean, last I knew, we still use gasoline and we still use chlorinated solvents. So there are products that are that we use every day that also can have an impact on the environment. It's how do we, we still have to deal with it. They're hazardous chemicals, and I think it's our we live in a modern society, and we have to balance these. So if we have these chemicals, then we have to figure out how to deal with it on the other end, and keep us, keep these exposures, and keep us, safe from these exposures. So I would say, yes, you still have to remediate it if you're still using it.
One thing to add, I think it's actually pretty similar to chlorinated solvents. I think a lot of people are now aware the releases into the environment are substantially smaller now than they used to be. And I think a lot of what we have to deal with is already in the ground. It's already in the environment. So I think we have much smaller inputs moving forward. Now we just have to deal with what's already gotten into the environment.
And I can add a little bit to that. I don't think it's a losing battle to continue to investigate contamination when PFAS are still, being used in daily products. Because first of all, not all PFAS are equal. I mean, we need to be concerned about the PFAS chemicals that we know are potentially harmful to humans and the environment. And many PFAS that are in these products are polymer PFAS. So like, for instance, Teflon. And polymer PFAS are such strong molecules that they will not even begin to break down unless they're exposed to very high temperatures, like 400 degrees Celsius. So just because PFAS, is in a product like that, like a polymer PFAS, does not mean that PFAS is going to make its way into the environment. So, enforcing the MCLs will most obviously importantly protect the drinking water of the United States, but as I mentioned earlier, many states are going to adopt these now as groundwater standards, and sometimes even as wastewater discharge limits for industry. So having the stringent limits like this for cleaning up groundwater at contaminated sites or regulating industry discharges is going to increase the progress and mitigation approaches that we're using at these sites.
All right. But is there, I mean, this is my own thought, but I think about this with climate change all the time. There are climate solutions that get these kind of pie in the sky concepts. Like, what if we mess with the clouds in order to affect the climate on Earth, where we don't know what the repercussions might be? Is there any risk that any of the chemicals that are being created now to replace, some of these long chain dangerous chemicals that we're all talking about, that any of these new fixes might introduce new problems or just be a replication of the same problems?
I'm not sure we 100% know the answer, but
yeah, I mean, they got rid of asbestos and they brought in PFAS, right? So
yeah, right.
It'll still be a never-ending game of chasing our tail, I guess, with respect to that. But just advocating for clean air and clean water is important. I think we've come a long way since leaded gasoline. So, while I don't like the fact that there's PFAS everywhere, I think that we're on a trend towards something a little cleaner of an environment. So hopefully the trend progresses this way, and that industries that are aware of compounds being toxic would self-regulate themselves and get them out, as opposed to continually producing them to maintain profits, is something that I would hope that they could have a little more conscience about going forward.
That's a good point, because a lot of what people are concerned about are PFAS and PFOA. And we've really, the manufacturers have stopped using those products for a long time now. And that's why the inputs to the environment are coming down quite a bit. As for the newer chemicals, I'm not as sure. You just have to keep doing tests and be aware and check and test. And I think we're much more aware now than we were 20 years ago. So that's going to help quite a bit.
Like, we're looking for it now, and we weren't necessarily looking for it before.
I think we're a lot more aware of, let's make sure we do that testing. Let's find out what the effects are. And just the awareness is much higher. Yeah. And public awareness is higher too, which makes everybody check that much harder as well.
And the fear of litigation, presumably, as Liz mentioned, this is becoming quite a theme. Yeah. All right, so here's a question that came in that, Tony, I was hoping you could address. Any advice for tribal governments, including recommendations for incorporating PFAS testing into phase 2 site assessments?
Sure. Yeah, I'm kind of reading that as a question for, they're kind of just getting into it maybe. And the recommendation that I would have is to be very consistent with your PFAS sampling methodology, develop, a consistent scope of work and a quality assurance plan, if you will. NYS DEC, we have a PFAS sampling guidance document that can be referenced online if you just Google New York DEC PFAS sampling guidance, because it's really important to have proper samples. I know Liz can attest to the importance of sampling groundwater from a permanent monitoring well and not just, grab sample from a turbid temporary monitoring well. So yeah, you just really need to be consistent with your sampling and utilizing all of the duplicates, matrix spike duplicates, stuff like that to assure you have quality data. And then of course, treat it like any other compound. If you're going to be trying to identify a source, you don't just poke 3 samples right where you think the source is. You also want to have, like Grant alluded to earlier, sample locations that are indicative of background or potential offsite contributions, so that you have kind of a good spatial trend of data, groundwater flow direction, and you can really identify if you have something indicative of just background or something indicative of a localized source. So I'd say our DER 10 sampling guidance document and our state PFAS sampling guidance document are really helpful to kind of understand how to sample at multiple depths and take enough duplicates and whatnot to have good data quality.
Great. So this is sort of another remediation question, but I mean, what do you do to remediate a groundwater contamination problem when there is no real clear source at all? Maureen, maybe you could start us off on this.
Yeah, sure. That's the challenge. And so I think what you have to look at it, your particular site, where is the potential risk or where's the potential exposure? So regardless of, an immediate source, if my concern is, groundwater moving off site and potentially impacting, private wells, even if you don't know exactly where some of this has come from, you still can come up with a plan to mitigate that. So in that sense, that may be the overriding feature. Of course, if you can get back to where the source is, and I think that gets into forensics, and that may get into cost capture too, who's responsible in that piece. But at the end of the day, on the remediation side, you're just going to do your investigation on what you have to deal with and come up with a plan to deal with that, kind of regardless where the source is. So, and if you have an ongoing source, then that gets into your time frame. So if you can have another source, and like I think Grant has talked about in Tony as well, and mitigate that and that flux into it, that helps with the overall plan, but it doesn't mean you still can move forward. It just may take a little longer.
Sure. Grant, anything you would add to that?
Just one little thing, like I think there's going to be a lot of sites with, so it all depends on the context. If it's a small exceedance, is that coming from background or up gradient? If it's a really small exceedance, do you have to do something at the site, or is there natural attenuation with mixing down gradient? If it's a big exceedance and up gradient is all clean, then yeah, you can do your investigation, try and find your source, or do containment at the boundary. So it all really depends on the context of the site.
Liz or Tony, anything you'd want to add on this? No? Okay.
I don't have anything to add. Yeah.
All right. So I guess the last question that I'll touch on from that was submitted ahead of time is, what do you recommend for a community that is concerned about this? I know from my inbox, from my own reporting, a lot of, like, on the municipal level, there is so much concern, and yet there is so little, funding available. Like, cities they don't have deep pockets these days. This is not a time when places are flush. And so how do you encourage communities who are concerned about this to look into it? Where would be some funding sources they could look into, and where would they go for information to learn more? Go ahead, Tony.
Yeah, just with respect to New York, we have a variety of grant programs available for municipalities to apply for through our EFC, Environmental Facilities Corporation. If you go to their website and you look for grant programs, I've firsthand seen many small towns apply for and receive grant programs to update their water infrastructure. And I can't speak to it, but I think there's also some EPA programs available, some grant programs available as well. But I know at least New York does, and they've been successful already. Have approved a variety of requests.
Go ahead, Liz. Did you have something?
I mean, I think most of the states have a lot of grant programs available right now from the federal government as well. So for municipalities to clean up, public water and drinking supplies and things like that. So that's, if they need to do that, that's one avenue for them. It's important. I think also we need to educate the community too. We need to educate them about what they're throwing down their septic system, things like that, right? I mean, because sometimes we're contributing it to our, to the problem.
If you could call out any specific things that you wish people would stop putting down their septic system to contribute to this problem, what would those things be?
Well, probably like carpet cleaning, wastewater, copper cleaning, wash water. That's a number one that comes to my mind. I don't know if anybody has anything
Hey,
else.
You do have carpet cleaning wash water though.
Well, I mean, maybe we need to contain, I don't know. I know for professional carpet cleaner, like they'll take it away and I don't know where they dispose of it, but it's not going into our septic system. Schools are, sometimes are putting carpet wash water down the drain, floor wax.
Maybe it's the
materials,
difference between a septic system versus another system that has a treatment component to it too. So if you start differentiating in that manner. I mean, the other thing I just
a lot of
bring,
these
is the
go ahead, Mary.
cost. I just want to bring up the cost. They're everywhere, and the amount of money needed to clean this up is massive. And I think that's really one of the challenges, and why maybe not as much has happened as quickly as people would like, is it's really a resource thing too. So it's still a challenge.
All right, well, unfortunately, that is all the time we have for today, but thank you all so much for joining us. Thanks to those who tuned in. This has been really fascinating, and appreciate all your time and help today.
Thanks, everyone.
Great, thank you.
Thank you.
All right, thank you very much, Sabrina and panel. That is going to be the end of our webinar today. If we did not get to your question, someone will make an effort to follow up with you. Just a couple quick reminders. We will be sending out a brief survey. We really appreciate your feedback. So please take a minute to let us know how we did. Also, you will receive an email with a link to the recording as soon as it is available. And thank you again very much to our panelists, and thank you to Sabrina for moderating today's panel, and thanks to everyone who could join us. Have a great day.